Okay, this is the P4 paper from October 22. It's question number 2, which is a partial fractions question. That's chapter 2, and it's going to lead on to an integration of partial fractions, which is chapter 7, obviously. Okay, let's make a start. Part A, it says express 3x all divided by 2x minus 1, x minus 2 in partial fraction form. So nothing complicated with this one. Don't need to do any division. There's no repeated factors here. This is just a over 2x minus 1 and b over x minus 2. If I'm going to look at this right-hand side, and if I'm going to add this together, I do that times that, and those two multiply together. So that gives us a x minus 2 plus b 2x minus 1 all over 2x minus 1 x minus 2. Well, that's going to be the same as that left-hand side, so 2x minus 1 x minus 2. So what that means is I can now, and I always say what I'm actually doing here, I can equate the top lines, equate the numerators here, and so I get that 3x is equal to a x minus 2 plus b 2x minus 1. So at this stage, what we want to do is to choose a value of x. I'm going to choose x equals 2, but a value of x so that I can make that 0 and get rid of an a, or so that I can make that 0 and get rid of the b. I'm starting off by getting rid of the a first of all. So if I choose x equals 2, I get 6 is equal to a times 0, so that's going to disappear, and b times 4 minus b times 3. So I end up with 3b equals 6 there, or in other words, b equals 2. If I choose, right now I want this to be equal to 0, so in order for 2x minus 1 to be equal to 0, I'm going to choose x working out to be equal to a half this time. So when I do that, I'm going to get 3 times a half is equal to a half minus 2 plus b times 0. That's the whole point, is that goes. So I get 3 over 2 is equal to, that's minus 3a over 2. Okay, so I get a equals minus 1. Quite often we get relatively straightforward constants because of what we're going to do later on with the integrating. So here, let's make sure I just answer my question. It's 3x over 2x minus 1, x minus 2 can be written down as, I'm just going to keep it in the same order, so minus 1 over x minus 2, no, over 2x minus 1 plus 2 over x minus 2. Okay, so I've managed to do the first part, which was to express that in partial fractions. Always have just a little quick check here that these are the same as each other. They could introduce some cheeky little constant, but they haven't here. This is just the integral of b is the integral of a in effect. We've got to do it between limits of 25 and 5. And really importantly, we've got to end up with log of just a single log k there, not anything more complicated with our terms. So for part B, what we're saying is the integral between 25 and 5 of 3x over 2x minus 1 x minus 2 dx can be split up into then the integral between 25 and, equals the integral between 25 and 25 of minus 1 over 2x minus 1 plus 2 over x minus 2 dx. Now, some of you will be able to go do this really, really quickly. I'm just going to slow it down in case there are people that are struggling with this. But we need to know that the integral of 1 over x straight away is log x. If I've got a function here, so I've got 2x plus 3 then, the integral's still log 2x plus 3, but because of the 2 there, that would become a half log 2x plus 3. If you're struggling with that, you're going to need to go back and do a bit more revision before you carry on with this question. The only thing I would do, if I was a little bit concerned, is I might take the minus 1 and the 2 out of the bracket. So I might say minus 1, integral between 25 and 5 of 1 over 2x minus 1 dx, plus 2 integral of 1 over x minus 2 dx. A lot of you will not need to do that, but it might just make things a little bit simpler for some people then. So if I'm integrating the first one, I've got log 2x minus 1, but then because of the 2, I've got a half log 2x minus 1. Once I've done that, I can put the minus back in. If I do the other part, I've got plus log x minus 2. No issues with that at all. Log x minus 2, 1 over x minus 2 is just log x minus 2. And again now, we can put the 2 back in there, and that's going to be between 25 and 5. And now what I want to do is I want to make these into a single log answer. Now, my students will be screaming at me at this stage, say, sir, you keep reminding us that it's log modulus 2x minus 1 and log modulus x minus 2. And it is, and I will put those in, but that comes to the fore more depending on what these values are in here. Okay, I've already done this question before, and I know that there's no log of a negative. But the whole point about having the modulus in is if this value here worked out to be a negative when you did x minus 2, you can't do the log of a negative, so then the modulus comes into its own there. Still put it in ideally, so I'm going to put it back in now. And what I'll do, go and have a look at other videos I've done, and you'll see where this actually then is far more important depending on what the examiner is testing for me here. But in order to do this, what I want to do first of all is to turn this into a single log. So we're going to use the idea that log A minus log B is log A over B. And we're also going to use the idea that n log A becomes log A to the power of n. We're going to do those because I want to make this thing a single function here. So the first thing I'm going to do is the powers, and I'm going to say, okay, this equals log 2x minus 1 to the half here. Keep the minus in there. And this equals log x minus 2 squared. So all I've done is taken that power up and taken that power up. And again, you can see I keep dropping the modulus sign as I'm going through it. I'm just going to leave it for the time being for this one. So we get that between 25 and 5. And then if I've got log A minus log B, I can now write this down as log x minus 2 squared all over 2x minus 1 to the half. Okay, so all I've done, move that over a bit. All I've done there is to combine that together to be a single log now. So I'll tell you what, let's leave it as the modulus and keep jumping about backwards and forwards between those. Doesn't make any difference with this one because none of these are going to be a negative. And we're doing that between 25 and 5. So because I've got this as a single log value now, it's going to make it much easier. Put 25 in, put 5 in. When I put 25 in, obviously I've done this before, it works out to be 529 over 7. Minus putting the 5 in works out to be log 9 over 3. And then if we combine those as a single log, it works out to be log 529, log 529 over 21. I'm going to stop there because our alarm is going off, but that's how you do that question.